We are going over the worksheet that says, what, section 2.6, right? So that covers the whole entire section 2.6. We had it broken down into 3 sections, A, B, and C. So this just covers the whole thing. And remember, taking a quiz on this tomorrow, okay? Only 5 questions. I looked at it just a few minutes before you guys came in. It's actually fairly simple as far as the problems that we've been doing, okay? So I didn't take like all the real difficult problems and put it on there. I took like the normal average, easier to mid-level, I guess, if you want to consider it that, problems. Everybody got that? All right, so what are we going to do here?
Multiply.
We have to solve for y first of all, right? That's what we're trying to do. And then, yeah, go ahead.
Multiply. Since if you factor out the quadratic on that
Right here.
quadratic
Yep.
thing, it turns into y minus 3 and y minus 4.
Okay. Stop right there. Stop right there, because we want to just go a little bit at a time. So watch what I'm going to do. I'll do this real quick and easy. So we're going to take that, and we're just going to factor this, right? And go ahead, Tiffany. What does it come out to be?
Y minus 3 and y minus 4.
Yep, minus 3 minus 4. Very good. Okay, we did that. Now what?
Multiply the 3 on top by y minus 4, and the 7 on top by y minus 3.
Well, you got to find a common denominator, and we're going to actually multiply this by both of them, y minus 3 and y minus 4, because that would be your common denominator. All right, so for instance, let's go back in time when you're a little kid. What if you had this, 3 and 5, right? And let's say you had this was, I don't know, x and y. What if you had something like this? What would the common denominator be with 3 and 5? 15. What did you do to those two? You multiplied them, didn't you? So what do you do here? You multiply that by 15, which is what? 3 times 5, isn't it? You follow me? No, I can't do that. Because I can't just arbitrarily multiply this by a 5 and multiply this by a 3. Remember, because whatever you do to one side, you have to do to the other side. So over here, I'm only multiplying this by 5 and only multiplying this by 3. I'm not doing the same thing to the whole entire side. I got to do the same thing to the whole entire side, right? So I can't just multiply this by a 5, and I can't just multiply this by, or whatever, I multiply this by a 3 and multiply this by a 5. I have to multiply by a 15 to get rid of it. I'm still seeing puzzled looks. You don't understand that? Because watch this. Let's go back to this one. Forget this one. I don't think this is helping you. Let's go back to this. My point is to multiply by a common denominator. So the common denominator, that should have been, the thing that we did over here should make sense with the common denominator, doesn't it? If all I said was find the common denominator, you'll go 3 times 5. Everybody understand that? So if I said what is the common denominator with this whole thing right here, it would be what? Y minus 3 times y minus 4. Everybody see that? It's kind of like the 3 times 5. So I have to multiply this by y minus 3 and y minus 4. But remember the rule for algebra. The rule for algebra says whatever you do to one side, you have to do to the other side. So if I only multiply this by y minus 3 and only multiply this by y minus 4 so that they cancel out, I'm really not doing the same thing to both of those, am I? I'm multiplying this by y minus 3 and multiplying this by y minus 4. I'm not doing the same thing to both of them. I have to do the same thing to everything. You follow me? I can't just pick and choose what I want to multiply by certain numbers. I can only multiply the whole entire left side by one particular thing, not by this separately and this separately. Does that make any sense at all? I don't know how else to explain it. But just remember it, okay? Whether or not you understand why we do this or not, eventually after you do this for a while, it'll start making sense to you. But right now, just understand to multiply by the common denominator. So if I multiply, look, I multiplied that whole left side by y minus 3 times y minus 4, didn't I? Okay? And that's the rule for algebra, right? Whatever you do to one side, you have to do to the other side. Yeah? Okay. So over here, what do I have to do? I got to do the same exact thing, right? I have to multiply it by... Right, we will eventually, but we got to make sure we know why we got just a 5. So watch, I multiplied the left side by y minus 3, y minus 4, and I multiplied the right side by y minus 3, y minus 4. I can't just pick to say, oh, let's just multiply this by y minus 3, and let's just multiply this by y minus 4. right? I have to do the same thing to both of these. Okay, I think that's about as much explanation as I can think of to give. So look what happens here. When I multiply this by y minus 3 times y minus 4, look what happens. This thing cancels out with this, doesn't it? And I'm left with a y minus 4 times 3.
It's 3y minus 12.
And this right here, yep, cancels out. Agreed? Look over here. What cancels here? Everything, right? Except for the 5. That cancels, and that cancels. And like Tiffany said earlier, we're going to be left with a 5 right there.
Okay.
So now let's see what we get. Go ahead, Tiffany. What do we do with this y minus 4 and this 3? We multiply them together. So give me one good math word. What do we do? Distribute, right. So let's distribute. So go ahead, Tiffany. What do we get?
3y minus 12.
Right.
7 times y minus
Which
3
is?
equals 7y minus
Right.
21.
Good. All right, so we just distributed all in one shot, okay? It's kind of messy. We just said, hey, let's just multiply. We can multiply that in our head. That's pretty easy. So I just take 3 multiplied by this. I get 3y minus 12. Took 7 multiplied by this. I get 7y minus 21 equals. Now, look, all that stuff canceled, so I'm just left with a 5 right there. Now it's a piece of cake after that.
Add all the like.
Yeah. Tell you what, just to save some time, I'm not going to do the rest. You can do the rest, okay? That's baby stuff. You can do that. That was the hard part right there, what I just did. Does that make sense to you?
Yeah.
What we did? Okay. So that was 3. Let's do 5. Again, I'm recording this, so if you need to check it again, if I went a little too fast. I actually got a couple comments yesterday. Finally, I haven't gotten like from people I don't know. They said they helped them from stuff I did last year. I guess people do searches on YouTube, you know, for certain topics, and they pop up. So one kid said something about, you know, thank goodness because I'm taking a test tomorrow and I didn't understand it. Now I understand it or something. I was like, yeah, that's cool. So that made me feel good. People I don't even know. All right, here we go. We're basically doing the same thing here, aren't we? Except the common denominator is a little bit tougher on this one. I got a 14, 28, and 20. Does anything pop into your head real quick as far as common denominator?
140?
Is that what it is? Might be. I don't know.
Okay, 140x?
Yeah. Well, I'm saying I literally don't know. Okay. I'm not just saying that. I really don't. So what I'm going to do is I'm going to come over here, and you may be right. I'm not saying you're wrong, but I want to figure out how to do it. So I'm going to take those numbers 14, 28, and 20, and I'm going to figure out how to find my common denominator. We've done this on several occasions. Do you remember doing this? Listing them out. I got 3 columns here. What do we do with these? Break them down into their primes, into their prime factors. Right, they're prime factors. Okay, so that's easy. That's 2 times 7. So I got that. What about this one over here? It's 4 times 7, right? Or 2 times 2 times 7. And then 20 is 4 times 5, which is 2 times 2 times 5. Remember the little routine we go through here? We look to see what numbers show up, right? They don't have to show up in all 3 of them. They just have to show up anywhere. So I got a 2 here. Well, I got 2 2's here and 2 2's here. So which one do I pick? The one that shows up the most number of times, which is what? 2 of them, right? Now I could pick either this one or this one. Don't pick them both. Just pick one or the other. Okay, so let's just pick these 2. I'm going to multiply those together in a second. Okay. What else shows up? 7. Okay, but I got 1 7 here and 1 7 here. Which one do I pick? Just one of them. Doesn't matter which one. Just pick one of them. What else shows up somewhere? 5. Now again, it doesn't have to show up in all 3 places, does it? It just has to show up somewhere. There's none here, and there's 1 here, so I just pick the 1. Now what do I do with those numbers that I've circled? Multiply them together. Okay, so 4 times 5 is 20, times 7 is 140, just like Tiffany said. Okay, that's how you get the 140. I mean, I literally wouldn't have been able to really do that in my head. Maybe if I would have sat there long enough, but it just didn't occur to me, you know, right away. Like 3 and 5, that occurs to me right away, doesn't it? What your common denominator would be. But 14, 28, and 20 didn't. So I do all this stuff. I find it's 140.
It
But
didn't occur to me yesterday either. It just occurred to me.
right. But also we have that x there. So we have to include that x as well, don't we? Because that shows up, right? It shows up in our 3 columns. I hope that makes sense. We've talked about that on several occasions, have we? And that really is a nice, easy way to figure out your common denominator. I really like that way. So what did we say it was? 140x, right? So what am I going to do? I'm going to multiply everything by 140x. Got it? So I multiply this by 140x. I multiply this by 140x. And actually, let's put parentheses around this one also. And I multiply this by 140x. So let's see what happens. 14 into 140. Well, that's easy. That's 10, isn't it? All right, but it's 10x, right? The x doesn't cancel out. We'll mess with that in a little bit. 28 times 140. What's that? What's that? Yeah, it goes. How many times is one? I should figure it out. Was it 5 times? Okay. So this goes into this 140. Right there, we'll scribble it out 5 times. But there's an x right there. Don't forget that. I'll tell you what. That's kind of scribbly, so I'll put the x right there. Everybody okay with that? We just went 28 into 140. That's all we did. And it's 5 times. What about this? 20 into 140. Oh, the x cancels too, doesn't it, on this one? So the 20 goes, how many times? Right, 7 times. And then the x goes too, so that cancels out with that. We okay? It really wasn't that big of a deal, was it? Looks kind of ugly, looks a little messy, so let's go ahead and multiply this stuff. So what do we have here? We got a 10, we got an x, -3, and an x. So 10 times -3 is -30. X times x is x squared. Okay? Just multiply the stuff that's left over. After I cancel the stuff out, then whatever's left over, I multiply it together. Plus, what about here? Nothing on the bottom, right? And that's the whole reason why we multiplied by a common denominator, so the denominators would all cancel out. That was the purpose of multiplying by a common denominator. So what's this? 5 times 16, what's that, 80? Is that right? So it's 80 what? X squared, right? Because it's a 5x times a 16x. Minus, what? What did I forget?
8b, not 8.
Oh, I put 8. I was looking up here. I was like, what did I do? What did I do? 80, right. 80, good. X squared. All right, minus just 5x times 1, which is 5x, equals, let's distribute this. There's only a 7 there, right? All the other stuff canceled out. Just have a 7, so you distribute that. That's 28x minus 7. Kind of looks like a quadratic now at this point, doesn't it? It's not quite there. We got to mix things around. We got to move things around to make it look like a quadratic, and we actually have to add some like terms as well. Let's do that. What's this going to be right here? -30x squared plus 80x squared. That's 50x squared. Subtract 28x from both sides. Subtract 28x. So 28 and 5 is what? That's 33. Is that right? Minus 33x. So that canceled out. Take the 7 and move it over to the left side. So we're going to do that by adding a 7. Right? So we added a 7 here. We added a 7 over here. And there you go. Now it's quadratic, isn't it? A little bit of an ugly quadratic. This possibly could factor. I guess it could. But you know what? These numbers are a little bit bigger than I'm used to. You know what might be a better way to solve for x here instead of trying to factor it? Because I don't even know if it factors to begin with, right? I could try all these numbers and try and try and try, and it may not even factor to begin with. I don't know if it does or not. But it might be good to just go ahead and do the quadratic formula. You think? Right? So when you have a situation like this, I always look to see if it factors. And I look to see if it factors easily. If it does factor, to me, it may not factor very easily. I don't know. It might. I might get it in the first shot. Who knows? But I'm not sure if that'll work or not. So we haven't done the quadratic formula in a while. So let's go ahead and do it. So x is equal to -b. Well, the b is -33, so -b would be +33. Plus or minus the square root of b squared. Now I have no idea what that is. Somebody do that for me. Actually, I got a calculator right here. Oh, look at this. I put a different calculator. Isn't that cool looking? It's like a see-through calculator. I don't know if I like that or not, but it's kind of busy looking. But anyway, what am I doing? 33 squared, right? 33 squared. It does give you a little bit of a headache, doesn't it, with all that craziness? 1089. All right, so 1089. That's b squared minus 4 times a, which is 50, times c, which is 7. Who knows? With these numbers, it might have been easier to try to factor it. And this is over what? 2a, right? 2 times 50. And then we just have to just use a calculator for this stuff, right? So let's see what we get. Can we do this in our head? What's 4 times 50? That's 200, isn't it? 200 times 7 is 1400. So it's 1089. So it's 1089 minus 1400. I did that right, didn't I? 1400? Okay. And that comes out to negative 311. Is this one of our answers? Did we do something wrong? I don't remember getting an answer this ugly. What number was this one? What was it? 5? I said 1/4 and 14 over 5. We messed up somewhere. Either that or the answer that they gave is not the answer to this problem. Did anybody actually get the answer to this problem? You got it? You got it right? Did you get these numbers right here that we're getting? You did? Okay. Did you do it with Ms. Bonsbach? Okay. And so she got this negative 311 in there? Okay. All right, maybe the answer, because they've been wrong before, haven't they? So I have a feeling that they might be wrong on this one, because this is going to come out to an I, isn't it? Right? Because you got a negative inside a square root, and that's not what the answer is in the book. So, and what is that? Square root of negative 311, is that what I said? Over what? 100? And really, that's just about it, isn't it? Except for what? That thing right there. Put a I in front of it. So it's 33 plus or minus. Did anybody actually get this answer besides Norval? Did you? Yeah. So that looks like, that's okay if you got help with it. It's no problem. That looks like that's the answer right there. All right. So the answer I read off, this seems wrong. Yes. So I should probably fix that on my answer sheet. So next year I'll know. All right. Good. Well, that makes some of you feel better, right? Because that's what you got. And that's what the answer is. Yeah. So I figure if you guys got it and I got it, it's probably the right answer. All right. So that was 5, right? Let's do 7. Let's do blue. So it's 2m to the negative second plus 7m to the negative first minus 15 equals 0. Alright, let's do this kind of quick. This is the one, this is by substitution. So we let x equal, remember, it's always this one right here, isn't it? Let x equal m to the negative first. So let's replace it now. So this is going to be 2x squared plus 7x minus 15 equals 0. This probably factors, right?
Yeah.
Alright, Tiff, what'd you get when you factored it? You got a 2x and an x, right?
Yeah.
And then what else did you get?
I got 2x.
Just look at it.
I got 2x minus 3 and x plus 5.
Okay. Alright, so let's see if that works. The outside, the first and last works, right? The outside and inside. So that's positive 10, that's minus 3. Yep, it's positive 7, and that definitely works. So what do we do with this stuff now? We set it equal to 0. And we set this equal to 0. So add a 3, divide by 2, so x is 3 over 2. Subtract a 5, so x is negative 5. Is that my answer? Do I circle it? No, I'm trying to solve for what? It says solve. Solve for what? M, right? So I got to plug it back into this thing. So x is m to the negative first. So really, m to the negative first is equal to 3 over 2, and m to the negative first is equal to negative 5. Now, what do we do with this? M to the negative first, I want m, right, to the positive first. So what do I do with this? I just flip it. That's right. I take the reciprocal, or the inverse of it. So that'll give me m. So if I flip this one, what do I do to this one? I flip that one. So that's how I get to 2/3. Same thing here. Flip this, I get an m. Now I flip this. Now, I don't change the sign, do I? The sign still stays there. So I just take the reciprocal of it. So what is it? Negative 1 over 5.
I think when you rounded off, you said that t equaled.
This is number 7. 2/3 and negative 1/5. Yeah, it's right on my answer. All right, what's another one? Let's do another one real quick. Let's not do one of those just because of time constraints here. Let's do number 11 and see if we can do 11 and 12. Okay, see if we can. I'm going to go kind of quick, but you can always go back and look. All right, here's 11. Remember I said hint on this one? Alright. Equals 8. Alright, so what are we going to do here? We've got to get rid of the square root. So we square both sides, right? So if we square both sides, that gets rid of that square root. So I'm left with x squared minus 17 equals 64. Looks like a yeah, that's all we got to do, right? For that. There's no x's in here. So let's put everything on the left-hand side. So I subtract 64 and I subtract 64. So I've got x squared minus, that's 81, right? Equals 0.
Or you could have just put everything on the others.
I could have done that as well, right? Absolutely, I could have. So you could look at it a couple different ways. You could factor this thing, all right? This is a difference of 2 squares, right? If you wanted to do it like that. So that's going to be plus 9 and minus 9. Or you could have just, like Tiffany said, put the 81 on the right-hand side and taken the square root and get a plus or minus. That'd probably be a little bit easier, to tell you the truth. But let's do this way. So x plus 9 equals 0, and x minus 9 equals 0. So x is what? Negative 9, and x is positive 9. Or, if you want to write it nice and neat, plus or minus 9. We good? Or you could have done this like Tiffany said, take that 17 and put it over here. So you would have had x squared equals 81. This might be a little less work to do. Square root both sides, right? So x is equal to plus or minus what? 9. It'd be a little bit quicker.
That's how I did it.
Alright. Yep, that's a good way to do it. So let's do number 12. I think we'll have time to do that. Number 12. It's the square root of 2x plus 5. This looks a little more complicated. Oh, actually, this one is a little more complicated. I don't know if we'll have enough time to do this one. Let's try it. Okay, first thing we're going to do is we're going to add the square root of x minus 2 to both sides. So I've got this on the left side equals 3 plus the square root of x minus 2 on the right side. Now I'm going to go kind of quick, right? So square both sides, so that gives 2x plus 5. If I square this side, right, I've got to do a FOIL on this. So it's 3 plus the square root of x minus 2, and then it's 3 plus the square root of x minus 2. This stays the same. I'm not going to mess with that just yet. This one, let's FOIL it and see what we get. First is 9. The outside is 3, and the inside is 3 squared of x minus 2, and the inside is the same thing. So if I add those up, I get 6 squared of x minus 2. Skipped a little step there. Plus, you multiply them together, and then you just get the x minus 2. Told you I was going to go a little fast here. So 2x plus 5 equals... we'll just write it out. 9 minus 2 is what? 7 plus 6 square root of x minus 2 plus x. I kind of wasted a step there, but it's alright. Subtract an x from both, or excuse me, subtract a 7 from both sides, subtract an x from both sides, right? So that'll go, that'll go. So I've got x minus 2 equals 6 times the square root of x minus 2. Square both sides to get rid of that square root. So I square this, and I square this. Give me just a second, and we're almost done. Watch. X minus 2 squared is the same as x squared minus 4x plus 4 equals, this is going to be 36 times x minus 2. So it'd be 36x minus 72, right? And then do this. X squared, that would be what? Minus 40x plus 72 would be plus 76, right? Equals 0, and then I don't have enough time to do the rest, but you can factor, set it equal to 0, set them both equal to 0, x is that, x is that. So that's all you got to do is that little bit right there, then you get your answer. Okie doke. You won't even have anything that hard on the quiz, alright? You won't have anything that hard on the quiz.
So just keep